Chapter 4, Section 7, Quantitative Aspects of Microbial Growth. Well, we can do all those counts. We can count how many viable cells are there between, during the different phases of, bacterial growth. We can go through and, do viable cell counts, different optical densities. So now, what can we do with it? Well, we can actually go through and plot growth data. And by plotting the growth data, coming up with means to discuss the exponential growth, how quickly, things are going through a generation time. How many, increase in number of cells divided by time is a means of telling you what's the generation. How long did it take you to go from 1 to 2, 2 to 4, 4 to 8? These are things we like to sit there and be able to discuss and compare between bacterial species, between bacterial genuses. So we go through and we do the cell numbers versus time. We can plot them out logarithmically or arithmetically. By plotting out logarithmically, using the log scale of 10 to the blank, 10, 10 to the 2, 10 to the 3, 10, 100, 1,000, and it gives us a linear line. Linear lines are easy to follow, easier to sit there and describe the plot. If you were to go through and you were to plot out just the raw numbers, what you're going to see is the first few hours, the numbers are going to be very, very low. Then you're going to get a curve, and then they're going to shoot up as the numbers increase dramatically. Because think about it, just here within the first 5 hours, you go from 1 to 1,000. You add on one more time point, 6. Well, it was 1,000 here, now it's going to have to be up to 2,000. After that, 4,000, 8,000, and the numbers are just going to get so hard to sit there and be able to graphically represent, while at the same time graphically representing 1, 2, 4, 8, 16. Now we want to be able to sit there and know how quickly, time-wise, things are growing. How do we go from our beginning population numbers to another endpoint population number? Well, we have to take into account what we're starting with, because remember in the last section I mentioned how many bacteria you start off with as you're measuring the bacterial growth curve. Lag, log, lag, exponential, stationary, and all of that. Well, how many you start with will impact timing, will impact how many hours, when things will hit the plateau. So we have to take into account that, and we can do that by discussing at time n, here's our population. How did we get to that population? Well, here's what we started with, our initial inoculum, how many bacteria we started with, and then how many generations did we go through. And you can plot it out. You can plot it out using scientific notation. You can plot it out using logarithmic numbers, however you want. What this does is it gives us a means of comparing. Under these conditions, bacteria X versus bacteria Y. Bacteria X has a specific growth rate under these conditions. Any changes to this growth rate means that one of the variables has been changed. Which variable? Not enough of this, too much of that. Increasing and decreasing of this could be due to, changes in the media that we weren't aware of. Or we're trying to see, how do we increase, decrease the rate? So here's my variable. I'm going to increase, decrease certain components in a defined media to see how this impacts the growth rate.